use of Romex in a hazardous classified location is prohibited. The National Electrical Code prohibits the use of Romex in hazardous locations because of its non-metallic outer jacket. This jacket is not suitable for such environments. In hazardous locations, for example, the area around and above ground fuel tank and pump, wiring methods approved for hazardous locations must be used. This includes rigid or intermediate metal conduit with explosion-proof fittings, flexible metal conduit with explosion-proof fittings, and approved cable assemblies. For temporary wiring during construction, a temporary power cord can be run overhead to a box 5 feet above ground. The temporary power cord must be protected from physical damage and secured to avoid contact with any potential ignition sources. The temporary power cord must also be approved for outdoor use and have a rating suitable for the load and environment. Once the hazardous location is complete, the temporary wiring must be replaced with a permanent wiring method approved for hazardous locations. Additional considerations include the fuel tank and pump manufacturer's instructions, which should provide more information on electrical requirements and any special precautions. It is important to consult with a qualified electrical contractor who is experienced in hazardous location wiring to ensure compliance with all applicable codes and standards. When dealing with electrical installations, it is critical to adhere to the National Electrical Code, or NEC, and local regulations to ensure safety and prevent hazards. In the context of wiring a commercial warehouse with a fuel tank and pump, several key considerations come into play. Firstly, understanding the classification of hazardous locations is paramount. The presence of flammable liquids like diesel fuel introduces the potential for explosions or fires, necessitating specific wiring methods and equipment. Romex, or non-metallic sheathed cable, is generally not permitted in hazardous locations due to its lack of protection against mechanical damage and its potential to propagate flames. Instead, wiring methods such as rigid metal conduit, intermediate metal conduit, or explosion-proof cable assemblies are required. These methods provide a robust barrier against physical damage and contain any potential explosions within the system. Secondly, the NEC outlines specific requirements for wiring in hazardous locations, which are typically classified as Class 1, Division 1, or Class 1, Division 2, depending on the likelihood of flammable vapors being present. Class 1, Division 1 locations are those where flammable vapors are continuously or frequently present, while Class 1, Division 2 locations are those where flammable vapors are only occasionally present. The choice of wiring method and equipment must be appropriate for the specific classification of the hazardous location. Thirdly, when installing wiring for a fuel tank and pump, it is essential to follow the manufacturer's instructions and recommendations. The manufacturer may specify particular wiring methods, equipment, or grounding requirements to ensure safe and reliable operation. Additionally, it is crucial to properly ground the fuel tank, pump, and all associated electrical equipment to prevent the buildup of static electricity, which could ignite flammable vapors. Fourthly, the use of temporary wiring during construction requires careful consideration. While temporary wiring may be permitted in certain situations, it must be installed in accordance with NEC and local regulations. Temporary wiring should be protected from physical damage, properly supported, and clearly identified. Additionally, temporary wiring should be removed as soon as permanent wiring is installed. Fifthly, when selecting electrical equipment for use in hazardous locations, it is essential to choose equipment that is specifically listed and labeled for that purpose. Explosion-proof equipment is designed to contain any internal explosions and prevent them from propagating to the surrounding atmosphere. Additionally, intrinsically safe equipment is designed to limit the amount of energy available in the circuit, preventing ignition of flammable vapors. Sixthly, the size and type of conductors used for the fuel tank and pump circuit must be appropriate for the load and voltage drop requirements. The NEC provides tables and guidelines for determining the proper conductor size based on the amperage of the circuit and the distance from the power source to the load. Additionally, voltage drop should be minimized to ensure that the equipment operates properly and efficiently. Seventhly, overcurrent protection, such as circuit breakers or fuses, is essential to protect the wiring and equipment from damage due to overloads or short circuits. The overcurrent protection device should be sized appropriately for the ampacity of the conductors and the rating of the equipment. Additionally, the overcurrent protection device should be located in a readily accessible location. Eighthly, proper labeling and signage are important for identifying hazardous locations and alerting personnel to potential hazards. Warning signs should be posted in conspicuous locations to indicate the presence of flammable liquids and the need for caution. Additionally, electrical equipment should be clearly labeled with its voltage, amperage, and other relevant information. Ninthly, regular inspections and maintenance are essential to ensure the continued safe operation of the electrical system in a hazardous location. Inspections should be conducted by qualified personnel to identify any potential problems or hazards. Maintenance should be performed on a regular basis to keep the equipment in good working order and prevent failures. Tenthly, it is important to consult with a qualified electrical contractor who has experience in hazardous location wiring to ensure compliance with all applicable codes and standards. A qualified electrical contractor can provide valuable guidance on selecting the appropriate wiring methods, equipment, and installation practices. They can also assist with obtaining the necessary permits and inspections. In summary, wiring a commercial warehouse with a fuel tank and pump requires careful consideration of hazardous location classifications, NEC requirements, manufacturer's instructions, grounding, temporary wiring, equipment selection, conductor sizing, overcurrent protection, labeling, inspections, and qualified personnel. By adhering to these guidelines, it is possible to ensure a safe and reliable electrical system that minimizes the risk of explosions or fires. Additional information to elaborate on these points. Firstly, regarding hazardous location classifications, it's crucial to understand the nuances between Class 1, Division 1 and Class 1, Division 2. Class 1, Division 1 locations, as mentioned, have a high probability of flammable vapors being present under normal operating conditions. This could be due to frequent maintenance, leaks, or other factors. In these areas, all electrical equipment must be explosion-proof and designed to prevent any ignition of the surrounding atmosphere. Class 1, Division 2 locations, on the other hand, only have a potential for flammable vapors to be present under abnormal conditions, such as a spill or equipment failure. In these areas, equipment can be either explosion-proof or designed to be non-incendive, meaning it doesn't produce enough energy to ignite flammable vapors. Secondly, the NEC provides specific tables and articles that address wiring in hazardous locations. For example, Article 500 and subsequent articles provide detailed requirements for different types of hazardous locations, including Class 1, 2, and 3. These articles specify the types of wiring methods, equipment, and installation practices that are permitted in each type of location. Additionally, the NEC provides tables that list the approved wiring methods for different types of hazardous locations. Thirdly, when selecting electrical equipment for use in hazardous locations, it's important to consider the temperature rating of the equipment. The temperature rating indicates the maximum surface temperature that the equipment can reach under normal operating conditions. This temperature must be below the ignition temperature of the flammable vapors that are present in the hazardous location. Equipment with a high temperature rating may not be suitable for use in certain hazardous locations. Fourthly, grounding is a critical aspect of electrical safety in hazardous locations. Proper grounding helps to prevent the buildup of static electricity, which can ignite flammable vapors. Additionally, grounding provides a path for fault current to flow back to the source, which can trip a circuit breaker or fuse and energize the circuit. The NEC provides specific requirements for grounding in hazardous locations, including the use of grounding electrodes, bonding jumpers, and ground fault protection. Fifthly, when installing wiring in hazardous locations, it's important to use the correct type of fittings and connectors. Explosion-proof fittings and connectors are designed to contain any internal explosions and prevent them from propagating to the surrounding atmosphere. These fittings and connectors must be properly installed and tightened to ensure a tight seal. Additionally, it's important to use sealing fittings to prevent flammable vapors from entering the conduit system. Sixthly, the use of flexible metal conduit in hazardous locations requires careful consideration. Flexible metal conduit can provide flexibility and ease of installation, but it must be properly supported and protected from physical damage. Additionally, flexible metal conduit must be bonded to ground to provide a continuous ground path. The NEC provides specific requirements for the use of flexible metal conduit in hazardous locations. Seventhly, when installing electrical equipment in hazardous locations, it's important to maintain proper clearances from combustible materials. The NEC provides specific requirements for clearances from combustible materials, such as wood, paper, and textiles. These clearances help to prevent fires and explosions. Additionally, it's important to keep the area around electrical equipment clear of debris and obstructions. Eighthly, the use of intrinsically safe circuits in hazardous locations can provide an additional level of safety. Intrinsically safe circuits are designed to limit the amount of energy available in the circuit, preventing ignition of flammable vapors. These circuits are typically used for instrumentation and control applications. The NEC provides specific requirements for the design and installation of intrinsically safe circuits. Ninthly, when performing maintenance on electrical equipment in hazardous locations, it's important to follow proper lockout-tagout procedures. Lockout-tagout procedures ensure that the equipment is de-energized and cannot be accidentally energized during maintenance. These procedures help to prevent electrical shocks and other hazards. Additionally, it's important to use non-sparking tools when working on electrical equipment in hazardous locations. Tenthly, the documentation of electrical installations in hazardous locations is critical for future maintenance and troubleshooting. Accurate documentation should include wiring diagrams, equipment specifications, and inspection reports. This documentation can help to ensure that the electrical system is properly maintained and that any problems are quickly identified and resolved. In conclusion, wiring in hazardous locations requires a thorough understanding of the NEC manufacturer's instructions and best practices. By following these guidelines, it's possible to create a safe and reliable electrical system that minimizes the risk of explosions and fires. Let's delve into more detail regarding the practical applications and specific code references within the NEC that govern electrical installations in hazardous locations, particularly concerning fuel tanks and pumps. Firstly, consider the NEC Article 514, which specifically addresses gasoline dispensing and service stations. While the question mentions a diesel fuel tank, the principles outlined in Article 514 are applicable to other flammable liquid storage and dispensing areas as well. This article classifies areas around fuel dispensing equipment based on the likelihood of flammable vapors being present. For instance, the area within 18 inches of the dispensing equipment and extending upwards is typically classified as Class 1, Division 1. The area extending beyond 18 inches may be classified as Class 1, Division 2, depending on the ventilation and other factors. Secondly, within Article 514, specific requirements are detailed for wiring methods, sealing, and equipment. For example, Section 514. 11 specifies that wiring within the classified areas must be in rigid metal conduit, intermediate metal conduit, or type MI cable. These wiring methods provide a robust barrier against physical damage and help contain any potential explosions. Sealing fittings, as mentioned previously, are crucial to prevent the migration of flammable vapors through the conduit system. These fittings must be installed within 18 inches of enclosures that contain arcing or sparking devices such as switches, circuit breakers, and contactors. Thirdly, explosion-proof enclosures are a fundamental requirement in Class 1, Division 1 locations. These enclosures are designed to contain any internal explosions and prevent them from propagating to the surrounding atmosphere. The NEC mandates that all equipment installed in these areas, including lighting fixtures, motors, and control devices, must be listed for use in Class 1, Division 1 locations. The listing ensures that the equipment has been tested and certified to meet the stringent requirements for explosion protection. Fourthly, intrinsically safe systems offer an alternative approach to explosion protection in certain applications. These systems limit the amount of energy available in the circuit to a level that is too low to ignite flammable vapors. Intrinsically safe systems are commonly used for instrumentation and control circuits, such as those used to monitor fuel levels or control pump operation. The NEC provides specific requirements for the design and installation of intrinsically safe systems in Article 504. Fifthly, grounding and bonding are critical for electrical safety in hazardous locations. The NEC requires that all metal parts of the electrical system, including conduits, enclosures, and equipment, be bonded together to form a continuous ground path. This bonding helps to prevent the buildup of static electricity and provides a low impedance path for fault current to flow back to the source. The grounding electrode system must also be properly installed to ensure effective grounding. Sixthly, surge protection is an important consideration in hazardous locations, particularly for sensitive electronic equipment. Surges can be caused by lightning strikes, utility switching, or other electrical disturbances. Surge protective devices, or SPDs, can help to protect equipment from damage caused by surges. The NEC recommends the use of SPD in hazardous locations to improve electrical safety and reliability. Seventhly, when installing wiring in underground locations, it's important to use direct burial cable that is specifically listed for that purpose. Direct burial cable is designed to withstand the harsh conditions of underground environments, including moisture, corrosion, and physical damage. The NEC provides specific requirements for the installation of direct burial cable in Article 300. Eighthly, the use of fiber optic cable in hazardous locations can provide several advantages over traditional copper wiring. Fiber optic cable is immune to electrical noise and interference and does not conduct electricity, which eliminates the risk of sparks or explosions. Fiber optic cable is commonly used for communication and control systems in hazardous locations. Ninthly, when performing maintenance on electrical equipment in hazardous locations, it's important to follow a strict permit-to-work system. A permit-to-work system ensures that all necessary precautions are taken before any work is performed on the equipment. This includes verifying that the equipment is energized, isolated, and properly grounded. The permit-to-work system also requires that all personnel involved in the maintenance work are properly trained and qualified. Tenthly, the NEC requires that all electrical installations in hazardous locations be inspected and approved by a qualified electrical inspector. The electrical inspector will verify that the installation complies with all applicable codes and standards. The inspection process helps to ensure that the electrical system is safe and reliable. In conclusion, electrical installations in hazardous locations require careful planning, design, and execution. By following the NEC, manufacturer's instructions, and best practices, it's possible to create a safe and reliable electrical system that minimizes the risk of explosions and fires.